This is a lesson on solving similar triangles. Similar triangles are solved in much the same way as similar shapes or similar polygons of any number of sides, but triangles are so common, we find triangles in so many applications that it's worth looking at them by themselves. Okay, we have a situation here where a surveyor has the scale diagram and he would like to determine the width of the river. The measurements he made are shown, and we can see that there are some equal angles on this diagram. So what is the width AB? We're looking for this length right here. The first thing that I'm going to do for this problem is I'm going to redraw the two triangles, oriented the same way so it's easier to see which dimensions pair up. So I'm going to draw our little triangle. Let's get some, we'll just draw it quickly like this. And then our big triangle like this. Okay, for a little triangle, we have a right angle down here and a right angle down here for a big triangle. The right angle is labeled A for our little triangle, and it's labeled E for a big triangle. Okay, the right angle is then, we have one angle that we're using these two lines to indicate that these two angles are the same measure. These are both point C. So for a little triangle, A goes across to C, and that is a length of 28.9. And our big triangle, C goes across to E, and that is a length of 73.2. And the only other dimension we have is from E to D, which is going to be up here, is 98.3, and then that means this must be B. Constructing these two triangles is an important step. Let's look at it again. Here we have ECD on this triangle, ECD with our two dimensions, that looks good. This triangle, however, looks a little bit different because we have actually rotated it 90 degrees. So we've taken this triangle, picked it up and rotated it. So now instead of A being in the top left, it's in the bottom right. C in the top right, it's in the bottom left. This triangle has been rotated 180 degrees. Turned halfway around. So now these triangles line up. It can be easier to pair up corresponding sides. The reason we want to pair up corresponding sides is we want to find this length right here. So I'm actually going to label this length with a question mark so we can keep track of what we're looking for. To solve these problems, we can find the scale factor first. I'll show this method first, and then I will quickly show solving it by proportions as well. Scale factor is comparing corresponding sides. Let's call this one our model and this one our original. It is up to you, but using model, calling model the one we need more information on will make the math easier. So first, to find our scale factor, 28.9 divided by 73.2. I want to choose to compare corresponding sides where we have both so that we can find our scale factor. 28.9 divided by 73.2. And we get a scale factor of 0.395. So I'll round that to 0.395. Okay, using this information, we can now solve for 395 will be our scale factor. Our model is what we're looking for, line BA. And we want to use our original of 98.3. Multiplying both sides of this equation by 90. Oh, this is getting really messy. Oh, 98.3, because 98.3 divided by 98.3 is 1. If we go back to our calculator, 98.3 multiplied 0.395, and we're getting the width of the river is 38.8, or BA is 38.8.